Today I'd like to talk to you about the CSD MOF Collection. We released this just a couple of weeks ago as a CSD community feature. So that means it's freely available to download and doesn't require a CSD license for use. So hopefully now you can see my screen with Mercury on it. And what I will start with is this is the MOF entry in Mercury, and this is the CSD entry, and you can see this by the fact that we have the chemistry assigned to the structure. So we have here the circles of the aromatic bonds and the double bonds here of the porphyrin ring. But what I'd like to point out particularly is these bonds at the end here with the alternating long and short sections, and that's the quick, easy visual indication that this is a polymeric structure, and this is just a small fragment of a larger extended framework. And where you see these bonds, it indicates that there are polymer expansion options that I will show you shortly. However, the other things I'd like to quickly point out about this structure is if I go to the display option at the top, and we have a voids calculation here. So if I just choose these default settings and apply this, you can see that in the visualizer we have a representation of where the empty space is in this structure. And I'll also point out, in this case, we have 28.8% of the unit cell volume that is empty. And I'll contrast that to the structure from the CSD MOF collection. The final thing I'd like to point out here is if we go to the More Info tab at the bottom and look at structure information, this structure is in PNMA, which is an orthorhombic space group, and we have a Z value of 4. So there's 4 symmetry copies of this structure in the unit cell. So if I now bring in the CIF from the MOF collection, you can hopefully see straight away that as expected, since this is now in P1 space group with no symmetry options, we now have 4 times the structure we had in the CSD entry. But you can also see here that we don't have the chemistry assigned to these atoms and bonds because it's come from a CIF. It doesn't contain the information that it does in a CSD, but we have still retained these long and short alternating bonds because it's recognized as a polymeric structure. However, if at any point you have a structure and you don't think this chemistry has been assigned correctly, if you go to the Edit menu and Auto-Edit Structure, you can see you have options to identify polymeric bonds. So if at any point you import a structure into Mercury and you want to expand it as a polymer, you can ask Mercury to check your structure and assign this bond type to you. If I just assign this now, you can see this structure from the CIF now has the same chemical representation as it did in the CSD entry. Next, I'd like to go back to the void space. So I'm going to do this calculation again using the same settings, but you'll see now that the void space has increased. We've got 38% void space in the structure because, as I said, in the CSD MOF collection, we've removed those non-bonded solvents, and I think that's a perhaps more accurate representation of how much free space is available in this framework. And then the final thing I'd like to show you today is if I reorientate the structure, I'll go to the Edit menu and look at polymer expansion options. Now, as I said, since this is a polymeric structure, we have a different range of tools to help you get to grips with the framework topology. And you can see there's 2 basic sections. We have a selection option and an expansion option. And so if I just pick this first setting of expanding out a particular selection by a whole unit, and I click on this atom, you can see I now basically have double the structure I had before. It's added that same repeating unit on again. However, if I instead choose to expand by a subunit and I click on that same atom, you can see the expansion I get is a much smaller section, and I can click that again, and you can see here it's very slowly, gradually building up a structure that helps you get to grips with perhaps particularly complex arrangements. My next choice is I could choose to expand rather than by the selection, but expand by a symmetry related option instead. So in this case, if I now click on here, you can see that I get not just the one copy of the molecule, but every instance of that atom in the repeating unit gets expanded at the same time. And then the third expansion option we have available here is, rather than when you click an atom it growing the structure, you can prune the structure at the same point. So if I click on an individual atom here, you can see it removes that atom bond. That's perhaps more effective if I choose my lasso tool and I pick a wider section of the polymer, and it removes that whole section at once. So hopefully these tools will help you to get exactly the right image you want for your illustrations if you're using it for a paper or some kind of publication. And then finally, from the options, we have the expand all button, and that really expands the polymer at all points simultaneously, which gives you a very quick and easy way to grow this framework and see the full extent of the framework.